All right, good morning, Mr. G here with Service First Pros Heating and Air out of Georgia. It's October 5th, 2025. It's about 9:30 in the morning, and we've got about a 57 degree outdoor temperature. I'm here on a no heat call. Customer really didn't have much as far as description on what the problem is other than it's not heating. So we're going to get in there, find out what's going on, and see if we can help them out. All right, so our main complaint here is that this upstairs thermostat on a zoned system, when it's calling for heat, it will randomly switch it over to cool after several minutes. I'm going to get in here and check the programming on the thermostat. I've already pulled it off the wall and we checked the wires. It is wired for heat pump. This is an all-electric system. They do have batteries in there, which if you have a common wire is not necessary. In fact, with heat pumps I usually remove those. But let's go ahead and get into the settings. Alright, so on this T4 Pro thermostat, to get into the installer settings, we hit the plus symbol and the center button until it says ISU. Stands for installer setup. Let's go ahead and go down the list. First thing we got here, 120 and 4. That's just the scheduling option. They said they do not want it to be a scheduling thermostat, so we're going to bump that down to 0. 125 is just zeros for Fahrenheit, 1 is for Celsius. We're going to leave that. 200 for the heating type. Number 2 is heat pump, so we are set properly there. 205 heat equipment type is air-to-air heat pump, which is number 7, so we're good there. On 18, reversing valve for O, because this does energize O for cooling, and we're good there. 220, this is cooling compressor stages. It's a single stage, so we're going to leave that alone. 300, system changeover manual. 365, compressor cycles rating stage 1 through 3. We're going to leave that alone. We got 387, compressor protection. On a 1, it's a 1 minute compressor protection. Generally you want between 3 to 5, so we're going to bump that up. At 430, your minimum cool set point 50 degrees. 431, maximum heat 90 degrees. 435, keypad lockout, none. 702, number of air filters. You usually will set this if you want a filter reminder, where we're just going to go ahead and leave that off. Backlighting on demand. They sleep in this room, they don't want it backlit all the time, so we're just going to leave it set to that. 1410, clock format, 12-hour versus 24. 1415, daylight savings time. This is an area that has daylight savings time. We're going to leave that alone. 1420, temperature display or offset, plus or minus 3 degrees. We're going to leave that alone here at 0. And that's it. So it looks as though our thermostat is set properly. We're going to go ahead and switch it on to heat mode. I'm going to get up in the attic and we're going to see what happens. Alright, we got our vertical heat pump system. This is our air handler. Fairly small supply box on top. We've got our main duct for, it looks to be the upstairs. And then our supply duct for the downstairs. This is an April Air Zone Comfort Control zoning system. Right now we only have the upstairs heat turned on. It's on delay. I'm waiting for that to come on. Here is our board here. Just waiting for that to go ahead and switch on. So these here are for our thermostats, your upstairs and downstairs thermostat. And this is for our equipment out. So this goes to the equipment, which tells the equipment to turn on. This comes from the thermostats, which tells the board to tell the equipment to come on. I'll check back here once this thing starts up. Alright, we got it started up. As you can see, there is a call for, it's like O is energized, so call for cooling actually on the equipment side. So we got Y and G and O all energized. Checking the suction line here just to feel it, to see if it's getting hot or cold. Feels like it's getting cold. Yep. So it is definitely putting out heat mode. So what we're going to do is we're going to check the thermostat output on the upstairs thermostat. That's the one right here. Alright, so what we're going to do is we've got a call for O on this side that's energizing for cool. We're going to check O to common, see if we have voltage. See if the thermostat is telling it to cool. So let's go ahead. Let's get O and common, and we are good. So the thermostat is not telling it to cool. There's nothing in the wires telling it to the O to come on to cool. It does appear that it's inside the board. That's just a initial assessment. We're going to dig a little bit deeper and see what we can find. Here is our schematic for this type of board. Does not appear to have any setting switch on here that I can find at the moment to change whether the output is O or B for this system. We do have our dip switches here for zone 1 heat pump or gas. Let's look at it here, and our setting is for heat pump, electric. It does have a purge. It's got a 1/60-second delay, and CO445 controls the temperature at the system will cut out for freezing. It's set to 40 degrees. So the board is set up for a heat pump. It's just the signal through the board to the equipment going out. It's got O energized, and that seems to only happen on the upper thermostat. So we're going to test the downstairs thermostat and see what it does. Did find a little something else on this board. Only this top thermostat control has an O wire, whereas the bottom one does not. So this is set up as if you had a conventional thermostat in the lower level and the upper level had the master thermostat, which would tell the system whether it's in heating or cooling mode. We call these a slave thermostat, which would be your just a basic thermostat telling the system to come on, where O was energized all the time in cooling as long as the master thermostat was set to cooling, whether it was calling for temperature or not. And vice versa, if it's set for heating, you'd have O de-energized, whether it was calling the temperature or not. So all of this thermostat would do for the lower zone is just turn the system on, and the board will take care of the rest. Alright, so after a closer look here, we notice the red light means the damper is closed. This is our actual upstairs zone. This is our downstairs zone. We're going to go ahead and label that here and here, because as you can see, when we check our common to Y, we do have 27 volts. So this is the one calling, because I do have the downstairs one turned off. So it appears the downstairs one is our master thermostat, and it's a Honeywell thermostat, so it may not energize all the time. But if you did do look here, common and O is not energized, so this still should not be in the O on, because the master thermostat is telling it to be off. So we got a couple things going on here. First off, our master or downstairs thermostat does not have O energized at all, but we still have O energized up here, so the system should still be in heat even though this thermostat here is only calling on Y. Alright, so we turned the downstairs system on heat, and you can see the O wires off. It's energized Y, which brings the outdoor system on. We got 27 volts. We check the O. O is not energized, so that means that the system should be in heat mode. But if it's not sending any signal at all, go ahead and check W while we're at it. So nothing on W. If it's not sending any signal at all from this thermostat, the main thermostat, then O should never be energized, which means that when this comes on, whether it's heat or cool, that O should not be energized, because there is no O wire down here. So our major issue appears to be with the board itself. Basically, unless Y is energized on here, it's not going to switch over to heat. So you would basically have to turn the downstairs thermostat heat up higher to keep the system running in heat mode, and this thermostat basically just opening the damper. Also, this thermostat here showing that the damper is closed. I did not shut that thermostat off, so that damper should be open. Let's check if we're energized on Y down here. So that thermostat for the upstairs is not energized to Y. So let's go check that thermostat and see what happened. Alright, so this thermostat went into a delay, and that's why it's not on. Even though it has batteries, because the power was killed to the wires inside the thermostat, that's why it sensed that there was no power there and put itself in delay mode. So it should be on now. Alright, so this should be on now. We're going to check Y and common. We have 27 volts. Damper is still currently closed, so we're waiting on that to open. Should be a spring open damper. Could be stuck. So let me check that damper. Alright, we got an older style damper here. Motor's not overheating. Let's see if we can get this thing to open up. Alright, another issue. This damper here is energized because it's normally open, spring open, power closed. The damper is energized from the board, telling the damper to stay closed. So even though we have a call on this unit, the damper itself has a call to stay closed. Again, looks like we're going to need to replace this board. I'm going to go ahead and talk to the homeowners about that. Not much more you can do in that situation. I can do some creative wiring to get this to work in the time being. However, who's to say that it's not going to have more problems going in the future? So yeah, we're going to recommend replace this board. Next up, we're going to go ahead and open up this air handler, check inside of it, and make sure everything's working in there. You want to do a full system check whenever you're doing these. Don't just find the problem. Make sure there's no other underlying problems, whether it's related or not. Alright, checking the inside of the system. I did check the fan amps. Fan amps are good. We checked the heat strip amps while it was running. Heat strip amps are in proper range for this heat strip. No chattering in the contactor, also good. And as you can see, this fan is nice and clean. This cabinet is clean. Not seeing any issues with biological growth, which is common in air handlers, especially here in the South. Let's go ahead and check this. These can often be leaky. Oh, let's get that O-ring. I'm not seeing any bubbling or leaking from that. No residual oil, so it looks like we're good there. The air handler appears to be functioning properly. We're going to go ahead and check the outside now too. Before heading outside, we also do always check the filter. Filter was changed just a couple months ago. It's actually fairly clean. A little bit of particulate. And go ahead, check the ducts. Those ducts are dirty. You always want to check airflow before charged. That's your ABCs. Remember that. Especially with a heat pump in the heating mode. A dirty coil, even slightly dirty fan wheel, Dirty filter can cause high head pressures and cause a high pressure lockout, which can also be an issue for your clients. So, airflow before charge. All right, so we are about to check this outdoor system in heat mode. I've got the disconnect pulled right now. I want to get the starting amps, and we're going to go ahead and zero our pressures out, and let's hook up. So we, in heat mode, you're going to hook up your high side to your suction line here, and your low side to your always suction, because the reversing valve should be de-energized, allowing it to run in heat mode. Let's go get that hooked up. I highly recommend, if you're using gauges with hoses instead of the wireless no hose refrigerant check kit, that you get these fittings here. They can be a little tight to get in certain situations, but generally these no or low loss fittings definitely save your hands from refrigerant burns. All right, so let's go ahead and open this thing up, and let's check the starting amps, and then we'll also check the capacitor running amps for the fan, compressor, and then once we allow the system to run for a little while, we'll get the pressures. All right, we'll make a note before we check everything here. This is an ECM condenser fan motor, which means that you're going to see the brown wire on common. Don't be alarmed by that. If you check your schematic, it will show you that's where it's supposed to be. All right, so if we look on our schematic here for our running capacitor, we see Herm should be yellow. We have 3 yellow wires there for Herm. On common, you've got your R going to your contactor. All right, and you've got R for your fan, and the brown wire there also on common. So just like I said. All right, so what we're going to do is we're going to check all the amps on this, starting with starting amps. I can check the capacitor under load, but since I don't have a separate calculator, I'm going to do it manually here. So let's make sure that you always de-energize your capacitor, just in case. This is for your safety. Alright, so let's check. This is a 40 microfarad capacitor. We're going to set to our microfarads there, and we're only checking Herm and common, and we're at 39.9, which is a good reading. Make sure we get all the wires put back where they go. Alright, now that we're all hooked up, we're going to come over here, check our compressor common for our starting amps. This thing has been off for at least 5 minutes. You want to give it time to settle before you start it, because if you start it too soon after it's shut off, you're going to have high starting amps. Make sure that you set your max on your amps on your meter, and then go ahead and put the disconnect in. Alright, so our amps right here for starting our 23.3. That's fine for this size system. Let's go ahead and check our running amps. Running amps. Still going to be climbing for a little bit. Let's give it some time. Alright, so we allowed the system to run for a good 15 minutes. Our compressor amps are about 12.5, climbing just slightly. Our pressures are a bit high on the high side, being only 70 degrees in the house, and these are still climbing. Now bear in mind, that's because one of our dampers is closed, so that's restricting airflow. So I'm going to go up there, get that damper to open by disconnecting it from the board. It should spring open, and then that should bring our head pressures start to come down. Alright, so we're back in the attic. Got the system turned on, and now the system is not registering the downstairs thermostat, and it's running in cool mode again, even though the downstairs thermostat is on heat mode, temperature turned up. It is not in delay, and as you can see here, our downstairs thermostat has damper closed, only energizing down here, but when I did check the wires up here, it was energized to Y. So definitely got to get this board out of here. Alright, so overall assessment, the zone control board needs replaced. It keeps acting screwy. Sometimes it's sending the right signal, sometimes it's not. The thermostats are doing what they're supposed to be doing, but that board it's just not communicating properly. I was going to get you a picture or video of the pressures after all dampers were opened to show you the proper pressure readings, but I could not get this thing to cooperate, and I could have bypassed the board completely and wired it for that, but I'm a little short on time before my next call, so we're going to go ahead and recommend a board replacement. If you like the video, give me a like, subscribe, go ahead and turn on your notifications, leave me a comment if you liked or didn't like something that I did in this video. Comment on it. It's all good constructive criticism. I'm all for it. I'm not God's gift to HVAC, and neither are you. So let's all learn together.